Good morning. Am I audible? Please, anyone respond in chat box if I'm audible.
Sir.
Okay. And do not mark your attendance now. If you are asked to do so, then only mark your attendance. Harshita M. In the previous class, we were solving problems on composite functions of 2 or 3 variables. Let's take a new problem. In the new problem, if z is equal to f of x comma y, if z is equal to f of x comma y and u is equal to, I'm sorry, not u, x. And x is equal to u minus v, x is equal to u minus v, y is equal to u into v. Show that first case, u plus v into, show that u plus v into del z by del x is equal to u into del z by del u, u into del z by del u minus v into del z by del v. Second case, u plus v into del z by del y. This is equal to del z by del u plus del z by del v. Del z by del v. These two identities are to be established now. How is this z defined? Z is a function of two variables x and y. Right? Z is a function of two variables x and y. Both x and y are functions of two variables u and v. Therefore, z is a composite function of two variables u and v. We find del z by del u and del z by del v through x and y. First, we find del z by del u. Del z by del u. What will be the expression for del z by del u? Anyone? Del z by del u. Unmute yourself and reply.
Del z by del x into del x by del u.
Wait, I'll write del z by del x, okay, into del x by del u. What will be the next term?
Del z by del x into del x by del v.
No, x is over. Del z by del x.
Del y
into del y by del u. This is equal to del z by del x. Z is written symbolically here, so keep this derivative as it is. Del z by del x into del x by del u. This is partial derivative of x with respect to u. That means treat v as constant. Therefore, derivative of u minus v, this is x. Derivative of u minus v with respect to u is 1. Derivative of u is 1 and v is treated as constant. Therefore, its derivative will be 0 plus del z by del y into del y by del u. Differentiate y partially with respect to u, treating v as constant. Since v is constant, keep it as it is. Derivative of u is 1. 1 into v is v. Therefore, del z by del x plus del z by del y into v. This is the derivative. Similarly, we write del z by del v. Del z by del v. What will be the expression for del z by del v?
Del z by del x into del x by del v.
Yes, del z by del x into del x by del v. Next term, del z by del y into del y by del v. This is equal to del z by del x as is into del x by del v. Differentiate this with respect to v, treating u as constant. Then what is del x by del v? Minus 1. Therefore, minus plus del z by del y into del y by del v, derivative of y partially with respect to v, treating u as constant. What will be the derivative?
U.
Yes, u. These are the two required partial derivatives. Now we try to prove these two results. I'll take up this first one. This first one. Start with the right hand side. We'll take this first one. Start with RHS. What is RHS? U into del z by del u. U into del z by del u minus v into del z by del v. Substitute u into del z by del u. This is del z by del u. Multiply this equation throughout by u. What will be the resultant? U into del z by del x plus u into del z by del y into v. That is uv into del z by del y minus v into del z by del v. This is v. I'm sorry, del z by del v. This is del z by del v. Required is v into del z by del v. Multiply this equation throughout by v. What we get here is v into minus del z by del x. V into minus del z by del x plus v into u is uv into del z by del y. Therefore, this is equal to u into del z by del x plus uv into del z by del y minus into minus plus v into del z by del x minus into plus minus uv into del z by del y. This is equal to cancel uv into del z by del y with this minus uv into del z by del y. And from the remaining two terms, what is common factor? Del z by del x. Yes, del z by del x is common in both the terms. You keep it outside. As del z by del x comes outside, what we get within the brackets is u plus v. U plus v into del z by del x. This is what we require. This is left hand side. LHS of the expression u plus v into del z by del x. If it is clear, please make a note of this. We'll move to the next part of the problem. Take a note of this, or at least a screenshot of this. Is this clear? ಅರ್ಥವಾಗಿದೆಯಾ? ರೆಸ್ಪಾಂಡ್ ಮಾಡಿ ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಹಾಕಿ.
Yes, sir.
ಓಕೆ. Now second part. Second part. U plus V into del Z by del Y is equal to del Z by del U plus del Z by del V. Let's start with right hand side. Right hand side is del Z by del U plus del Z by del V. This is a very simple case. Del Z by del U, it's here. 1 into del Z by del X is del Z by del X plus V into del Z by del Y. V into del Z by del Y plus del Z by del V and del Z by del V is minus del Z by del X plus U into del Z by del Y. Now cancel this plus del Z by del X with this minus del Z by del X. And from the remaining two terms, we can take del Z by del Y as common factor. As del Z by del Y comes outside, what we get inside is U plus V into del Z by del Y. This is what we required left hand side. Hence the identity is proved. Next problem. If Z is equal to x square plus y square, Z is equal to x square plus y square, where x is equal to e power u into sin v, y is equal to e power u into cos v, e power u into cos v. Find del z by del u, find del z by del u, del z by del v as a composite function and verify the result by direct substitution. Two derivatives are to be determined, del z by del u and del z by del v. How is this z defined? Z is function of two variables, x and y. Z is equal to x square plus y square. Therefore, it is a function of two variables, x and y. Both x and y are x is equal to e power u into sin v and y is equal to e power u into cos v. They are functions of two variables, u and v. Therefore, z is a composite function of two variables, u and v. We find del z by del u and del z by del v through x and y. First, we find del z by del u. Del z by del u through x and y. What will be the expression? Del z by del u is del z by del x into del x by del u plus del z by del y into del y by del u. Substitute. This is equal to del z by del x. Derivative of z partially with respect to x, treating y as constant. Derivative of x square is 2x plus derivative of y square is 0 into del x by del u. Differentiate x partially with respect to u. Differentiate x, this is x, partially with respect to u. That means sin v is constant, keep it as it is. Sin v is constant, keep it as it is. Derivative of e power u is e power u itself into sin v plus del z by del y. Differentiate z partially with respect to y, treating x as constant. Therefore, derivative of x square is 0. Derivative of y square is 2y. 2y into del y by del u. Differentiate y partially with respect to u, treating v as constant. Therefore, cos v is a constant, keep it as it is. Derivative of u is e power u itself into cos v. Therefore, this is equal to 2 into x. It's given that x is e power u into sin v into e power u sin v as this plus 2y, 2 into y. Y is e power u into cos v. E power u into cos v. And this e power u cos v as this. This is equal to 2 into e power u into e power u is e power 2u. Sin v into sin v is sin square v plus 2 into e power u into e power u is e power 2u. Cos v into cos v is cos square v. Therefore, this is equal to, what is common factor here? 2 into e power 2u is common in both the terms. You keep it outside. 2 into e power 2u. Here also 2 into e power 2u. As 2 into e power 2u comes outside, what you get within the brackets is sin square v plus cos square v. That is equal to 1. Therefore, this is equal to 2 into e power 2u. This is one of the two required derivatives, del z by del v. Similarly, del z by del v. Del z by del v with respect to this variable through x and y. What will be the expression? Del z by del x into del x by del v plus del z by del y into del y by del x. Substitute. Del z by del x. Differentiate z partially with respect to x, treating y as constant. Therefore, derivative of y square is 0 and that of x square is 2x into del x by del v. Differentiate x, treating u as constant. Differentiate x with respect to v, treating u as constant. Therefore, e power u as this. Derivative of sin v is cos v plus del z by del y. Differentiate z partially with respect to y, treating x as constant. Derivative of x square is 0 and the derivative of y square is 2y into del y by del x into del y by del v, not x, del y by del v. Differentiate this with respect to v, treating u as constant. E power u is a constant, keep it as is. And derivative of cos v is minus sin v. Therefore, this is equal to 2 into x. Here x is equal to e power u into sin v. E power u into cos v as is. Plus into minus minus 2y. Here y is e power u into cos v. E power u into sin v as is. Therefore, this is equal to 2 into e power u into e power u is e power 2u sin v cos v minus 2 into e power u into e power u is e power 2u sin v cos v Clearly, these two are equal in magnitude. One is in positive direction and the other is in negative direction. Their sum is equal to 0. This is the second derivative, del z by del v. So please make a note of this. If you have any doubts, you can unmute yourselves and ask. Next part of the problem is verify the result by direct substitution. First, you write down these two directives. We'll move to that part. If it's over, let me know. Okay. Verify the result by direct substitution. Now verification by direct substitution. What is the definition of z? Z is equal to x square plus y square. This is equal to x square. It is given that x is equal to e power u into sin v. Therefore, x square is e power u whole square, that is e power 2u into sin square v. Plus y square is e power 2u into cos square v. Therefore, z is equal to, here e power 2u is common in both the terms. We'll take it outside. Then what you get within the brackets is sin square v plus cos square v, which is equal to 1. Therefore, z is equal to e power 2. Now differentiate this z partially with respect to u. Differentiate partially with respect to u. Treat v as constant. Derivative of z is del z by del x. I'm sorry, del z by del u. This is equal to derivative of e power 2u is e power 2u into derivative of 2u with respect to u is 2. Is this correct? This is what we obtained previously. Del z by del u is equal to 2 into e power 2. Again, differentiate the same expression with respect to v partially. Z is equal to e power 2u. Differentiate partially with respect to v. That derivative is denoted by del z by del v. This is equal to, this is partial derivative of z with respect to v. That means treat u as constant. Therefore, e power 2u itself is a constant. Derivative of a constant is 0. So what we have done is correct. Mark your attendance in the chat box, your name along with admission numbers. If you have any doubts in composite functions, you please unmute yourselves and ask. Otherwise, I'll move to the next topic. ನಿಮಗೆ ಏನಾದರೂ ಕಾಂಪೋಸಿಟ್ ಫಂಕ್ಷನ್ಸ್ ಅಲ್ಲಿ ಟೋಟಲ್ ಡೆರಿವೇಟಿವ್ಸ್ ಅಲ್ಲಿ ಡೌಟ್ಸ್ ಇದ್ರೆ you please unmute and ask. Okay, we'll go to the next part of the chapter. Jacobians. Jacobians. let u and v be functions. Let u and v be functions of two independent variables, say x and y. Of two independent variables, x and y. U is a function of x and y. V is also a function of x and y. Then the Jacobian of u and v with respect to xy is denoted by j. This is also denoted like this: j of uv divided by xy. You read this as Jacobian of uv with respect to xy, or this can be written like this: del of uv divided by del of xy. You read this as Jacobian of uv with respect to xy. All are same notations. And this is given by the determinant whose first row is del u by del x. You start with this here: del u by del x, del u by del y, del u by del x, del u by del y. And second row is, now take this v, del v by del x and del v by del y. This is the determinant: del u by del x, del u by del y, del v by del x, del v by del y. This is called Jacobian. It is denoted by j, or j of uv divided by x comma y, or del of uv divided by del of x comma y. ಯಾವ notation ಬೇಕಾದರೂ ಯೂಸ್ ಮಾಡಬಹುದು. This is what we call Jacobian. Suppose u, v, w are functions of three variables, say x, y, z. Then Jacobian will be equal to the determinant whose first row is del u by del x, del u by del y, and del u by del z. Del u by del x, del u by del y, del u by del z. And the second row will be, you can guess the second row: del v by del x, del v by del y, and del v by del z. You can guess this third row: del w by del x, del w by del y, and del w by del z. This is the Jacobian of u, v, w with respect to x, y, z. Please make a note of these two. I'll solve a problem for you. Okay, let's write a problem. Find the Jacobian of u, v, w. Mute your audio. Find the Jacobian of u, v, w with respect to x, y, z. With respect to x, y, z, given that u is equal to x plus y plus z, v is equal to y plus z, and w is equal to z. Find the Jacobian. U, v, w are functions of three variables x, y, and z. Therefore, j is given by, what will be the definition? del u by del x, del u by del y, and del u by del z. Del v by del x, del v by del y, and del v by del z. Del w by del x, del w by del y, and del w by del z. We first write this definition of J. Now this is equal to, substitute del u by del x. What is del u by del x? This is u. Now you have to tell me the derivatives. What is del u by del x?
One.
1. Del u by del y? 1. Del u by del z?
1.
1. Right. This is first row. Del v by del x, second row.
0.
0. Del v by del y?
1.
1. Del v by del z?
1.
1. Next, del w by del x?
0.
0. Del w by del y?
0.
0. Del w by del z?
1.
1. Right. All the derivatives are substituted. Then what is the value of this determinant? How do you find value of this determinant? ನಿಮಗೆ ಡಿಟರ್ಮಿನೆಂಟ್ ಎಕ್ಸ್ಪಾನ್ಷನ್ ಗೊತ್ತಿದೆಯಲ್ವಾ?
Yes, sir.
Okay. What is the value of this determinant? We need not expand this. Note ತಕ್ಷಣ ಹೇಳ್ಬೋದು.
1.
1.
1.
So there are two diagonals. This is the diagonal from left top to right bottom, correct? This is the diagonal from left top to right bottom, and all the elements here 0, 0, 0. All elements to the left of the diagonal are equal to 0. In such cases, value of the determinant is the product of all the three elements in the principal diagonal. One side of the principal diagonal elements are equal to 0. These three are equal to 0. In such cases, determinant is equal to product of all the elements in the principal diagonal. 1 into 1 is 1. Again, 1 into 1 is 1. Jacobian J is equal to 1. So please make a note of this. We have less than 1 minute left. Thank you. I'll continue the next class.